Hello my dear students, in continuation of our J questions PYQ series, we are going to discuss some more questions. So today's question is, for a plane electromagnetic wave given by this equation and magnetic field equation is this, the ratio of average electric energy density to average magnetic density will be. We are provided with an electromagnetic wave having the electric field equation as this and magnetic field equation as this. Okay. Now we have to find out the ratio of electric energy density to average magnetic energy density. So this is simply the application of concept. For an electromagnetic wave, the average electric density is always equal to average magnetic density. Both the densities, electric and magnetic, are equal in magnitude, and when we take the ratio of equal things we get 1. So the correct answer will be option number 3rd. And in terms of formula, the formula for electric energy density is 1 by 4 E naught square, and the formula for magnetic energy is 1 upon 4 mu naught B naught square, where mu naught is the constant for magnetic field and E naught is the constant for electric field. For electromagnetic wave, both these are equal in magnitude, that's why the ratio will be 1:1. The other question says, a planet has double the mass of the Earth. We are provided with the condition that a planet is having mass double the mass of Earth. Its average density is equal to that of the Earth. Average density of planet and Earth are equal. Any object weighing W on the Earth will weigh on that product. We have to compare the parameters of Earth and the other planet. So the mass is double of the planet is double, and the average density is equal to the Earth. Okay, and object weight on the Earth is W. So the simple concept is, we are provided with two planets. One is our Earth and other is planet P. Okay, according to questions, the mass on the planet is double on the Earth and average density is same. So we have to calculate, if an object is weighing W on the Earth, what will be its weights on the other planet. So according to the question, the average density is equal. So average density of the planet must be equal to the average density of Earth, and the density is simply mass upon density is nothing but the ratio of mass upon density is simply the ratio of mass upon volume. So the mass of the Earth is me upon the volume. The volume for spherical object is 4 by 3 pi r cube. So here we are putting the parameters for Earth and here we are putting the parameters for planet. Mass of Earth upon volume of Earth, mass of planet upon volume of planet. For Earth we are using E and for planet we are using P. So we can see 4 by 3 pi and 4 by 3 pi cancel out. We get me upon re cube is equal to 2me upon rp3. Why we have put in here 2? Because according to question, the planet has double the mass of the Earth. So the mass of the Earth is me. So mass of the planet must be 2me according to questions. Okay. Now on solving, we get Rp is equal to 2 raised to power 1 by 3 Re. This is a relation between radius. Okay, the radius of planet must be equal to 2 raised to power 1 by 3 the radius of Earth. Now the formula for acceleration due to gravity is G is equal to Gm upon capital R square. So we can equate the values of G for Earth and planet. G upon Gp is equal to, we just put the values and we get the ratios of Ge upon Gp. We get 2 raised to power minus 1 by 3. Okay, so we can write Gp is equal to 2 raised to power 1 by 3 Ge, and Wp must be equal to 2 raised to power 1 by 3 We. Now according to question, what is the value on the Earth? It is W. So on the planet it must be equal to 2 by power 1 by 3 raised to W. W is the mass on the Earth, or weight on the Earth. Weight on the Earth is W, and the planet is according to 2 raised to power 1 by 3 W. We just compare the given condition of the questions and the standard formula get the answer. Moving to the next part. The next part of the question is from current electricity topic. The resistivity of a semiconductor vary with the temperature which of the following curve. On seeing the relation, we know resistivity is inversely proportional to temperature for which semiconductor, and the required answer is option number 3. Okay, and if it is according to metal, for metal it is directly proportional, and for alloy it does not depend. That's why the relation is this. This is relation for semiconductor, this is for metals, or this is for alloys. This is the relation for resistivity and temperature curve. Moving to the next part, the next question. A monochromatic light wave, mono means single, chrome means color. A monochromatic light wave with a wavelength lambda 1 and frequency nu 1 in air enter the another medium. If the angle of incidence and the angle of refraction at interference are 45 degree, okay, the angle of incidence is 45 degree and angle of refraction is 30 degree, then wavelength lambda 2 and nu 2 of the refracted wave. Okay, now we have to relate the concept. The monochromatic light having wavelength lambda 1 and frequency nu 1 enters another medium at an angle of incidence of 45 and angle of refraction is 30 degree. We have to calculate lambda 2 and nu 2. So the options are the relation between the two wavelength and the two frequency. Now we can simply say 1 into sin 45 is equal to mu into sin 30. How we have written? We have written angle of incidence as 45 degree and angle of refraction as 30. So on solving we get mu is equal to root 2. Because mu is nothing. Mu is refractive index. It is the ratio of mu is equal to sin I upon sin R. We have used this for relation. Now the relation between refractive index and velocity is inverse. So we can say mu and velocities are inverse. Okay, mu and velocity are inverse, and also according to Cauchy relation, mu and lambda are also inverse. Okay, this is a relation between refractive index and velocity, and this is the relation between refractive index and wavelength according to Cauchy relation. So we can write mu 1 upon mu 2 is equal to V2 upon V1 is equal to lambda 2 upon lambda 1. Okay, this is according to this relation. Now first equation gives mu is equal to root 2, and other equation is relating mu, v and lambda using equation 1 and 3. On combining both the equation, we can write lambda 2 is equal to 1 upon root 2 times lambda 1 and V2 is equal to 1 upon root 2 times V1. The relation for frequency says nu is equal to V upon lambda. On solving we get V1 nu 1 is equal to nu 2. So the frequency is same. Okay, the frequency is same, and lambda 2 is equal to 1 upon root 2 lambda 1, because frequency does not change. Why it is not change? Because frequency is related to source of light, and the monochromatic source is there, frequency source is same, that's why frequency is a function of source. It does not change, frequency remains the same. Okay, whereas the wavelength changes, lambda 2 is equal to 1 upon root times the lambda 1. Moving to the next part, the next question is, a mass M is attached to two springs as shown in figure. We are provided with two springs having spring constant K1 and K2. Mass is attached to both the spring. The spring constant of the two springs are K1 and K2. For the frictionless surface, the time period of oscillation of mass M. Okay, we are provided with an arrangement in which the mass M is between two springs K1 and K2. We have to calculate the time period of oscillation. What we have to calculate? The time period of oscillation. For simple pendulum case, we get T is equal to 2 pi root M upon K. Okay, yes or no? For spring, we get M upon K, and for pendulum, we get T is equal to 2 pi root L upon G. Because it is a concept of spring, that's why we have used this formula. In spite of writing K, we write K equivalent. Okay, in this case, both the spring iron is parallel case, and for parallel case, the K equivalent is K1 plus K2. So M K equivalent value we get K1 plus K2. This is the required answer. That is the option number 4. This is simply the application of formula. Because these are spring in parallel, that's why we have written K equivalent is equal to K1 plus K2. Okay, and if it is in series, if the question is about series combination, then we can write 1 upon Ks. Ks denote for series is equal to 1 upon K1 plus 1 upon K2. This is formula especially used in case of series combination. Okay, now moving to the next part, name the logic equivalent to the diagram as shown in figure. Okay, we are provided with a diagram in which 5 volt supply is there, first circuit and second circuit, and this LED is glow. Okay, Now the concept says, according to the circuit, it is connected in such a way that this LED glows. Okay, so we can say what are the conditions to be satisfied for the LED to glow. This is simply the application of NOR gate. NOR gate, what is the NOR gate? Truth table for NOR gate. Now the first input is 0, 0, 0, 0, then we get output is equal to 1. Now the other circuit is, other condition is A is 1 and B is 0, then output is 0. Okay, so we can say when both are at 0, 0 position, though both input are 0, 0, then we get output is equal to 1. This is the required condition for which gate? NOR gate. NOR gate, that's why this is the truth table for NOR gate. Moving to the next part, the induced EMF can be produced in a coil by, okay, we are provided with the conditions, 4 conditions are there, and we have to select which is the best suitable for the production of induced EMF. So the first option says moving the coil with uniform speed inside the uniform magnetic field. Second option says moving the coil with non-uniform. First is uniform speed, other is non-uniform speed. Third says rotating the coil inside the non-uniform magnetic field, and the fourth says changing the area of the coil inside the box. Okay, so the correct answer is option number C, that says C and D are the correct explanation. Induced EMF is given by the formula for flux is phi is equal to B into dA. By rotating coil, the angle between the coil and the magnetic field changes. When we rotate something, then the angular value theta changes, and hence the flux changes by changing area, magnetic flux changes. Okay, so the option number 2 is correct, which says C and D are the correct method for induced EMF. Moving to the next part, here are we provided with 2 statements. One is assertion and another is reason. Assertion says when a body is projected at an angle 45, its range is maximum. Okay, R maximum. We have discussed in projectile motion. If you project something with 45 degree, it covers the maximum range. Reason says for maximum range, the value of sin 2 theta should be equal to 1. Okay, that's why we can see assertion and reasons are correlated to each other. Okay, for ground to ground projectile motion, horizontal range is given by u square sin 2 theta upon g. Okay, and we can say R will be maximum when sin 2 theta is maximum, because this formula says range is dependent on this sin 2 theta. If sin 2 theta is maximum, then we can say range is also maximum. That's why both the assertion and reasons are correlated to each other. Moving to the next part, next question. 2 identical circular wires of radius 20 cm carrying in current of √2 ampere are placed in perpendicular planes as shown in figure. Okay, we are provided with 2 circular wire, first named X and other is Y. Okay, first axis is X and other is Y, having a radius of 20, okay, and carrying current of √2 ampere are placed in a perpendicular. The net magnetic field and the center of the wire will be, we have to calculate the value of net magnetic field. So the net magnetic field is given by mu naught I upon 2r I for this horizontal and mu naught I upon 2r j for vertical. Now mu naught I upon 2r for I we can write √2 I ampere, current value is √2 I, and solving this value we get this, and adding the answer is 628 into 10 raised to power minus 8. So 10 raised to power minus 8 is already provided. So our answer for this Phillips type is 628. Okay. Moving to the next part, a steel rod bar has a radius of 20 mm and length. Okay, we are provided with a steel rod bar having radius 20 mm and length 2 meter. A force of 62.8 kilonewton sets along its length. Young modulus of steel is this, the longitudinal strain produced. This question is related to mechanical properties of solid. The formula for Young modulus is stress upon strain, and we know the Young modulus is related to length. So we can say stress upon strain. Which type of strain? Longitudinal. So we have to calculate the value of strain. Strain is equal to stress upon Young modulus, and stress is nothing but it's kind of force upon area. Stress is simply the force upon area. Okay, the force is 62.8 kilonewton, that's why 62.8 and 1000 for kilo, upon area. Area is pi r square, and Young modulus is given as 2 into 10 to the power 11. Okay, and radius we are provided with 20 mm, and solving and converting into appropriate units we get 25 into 10 to the power minus 5. This is the required value for strain. Okay, moving to the next part. The length of a metallic wire is increased by 20%. Okay, the length is increased by 20% and area is reduced by, area of cross section is reduced by 4%. Then the percentage change in the resistance. As we all know, the basic formula for resistance is R is equal to rho L upon A. Rho is the resistivity, L is the length, and A is the area. This is the original resistance. Now we can calculate the new resistance by simply new parameter. Length is increased by 20%, so we can say L replaces by 1.2 L. Why initially we have considered one value. For 20% increment we can write L changes to L to 1.2 L. Okay, and the area of cross section reduced by 4%. So initial area is A, the reduced area is 0.96 A. This is simply calculation based on percentage. Percentage means per 100, percentile means per 10, and we have calculated on 1. Okay, initially it is 1, and for 20% increment we can write 1.2 L, and the area reduces by 4%, that is 0.96 A. So R dash is equal to 10 by 8 R, that can be written as 1.25 R. The new resistance is 1.5 times the old resistance, and the value for old resistance is 1 and the new is 1.25. That means that is an increment of how many percent? 25%. The required answer is 25. This is simply the application of formula. Moving to the next part, the radius of fifth orbit of Li++ is ita. Taking the radius of hydrogen atom this, we have to calculate the fifth orbit of radius for Li++. So the formula for radius is Rn is equal to 0.51 n square upon z angstrom. Okay, now n is the orbit number. Okay, for Li++ we can write z is equal to 3. For fifth orbit we put n equal to 5. R5 is equal to 0.51. The square of 5 is 25 upon Z3 angstrom 10 to the power minus 10. On solving we get the answer is 425 into 10 to the power minus 12. Because in the question they have provided with the exponent value, so we have to convert this into this because of this type of condition given in the question. If the condition is not there, so this can be the answer. This can be the answer of the question. But according to question, they have already written this exponent value, so we have to convert our answer into this exponent form. Hence the correct answer is 425. Moving to the next part, a particle of mass 10 gram moves in a straight line with retardation 2x. Retardation is opposite to acceleration, where x is the displacement in SI units. Its loss of kinetic energy for about displacement is this. Okay, when one object is in retarding mode, it loses its kinetic energy. Why it loses kinetic energy? Because its velocity decreases, and the loss of kinetic energy is given in this format. We have to calculate the value of n. According to question, retardation is given as 2x, so we have written A is equal to minus 2x. We have used minus sign because it is retardation. For acceleration we are using positive sign. Now retardation is given as A is equal to minus 2x, so we can write A as V dV upon dx is equal to minus 2x. If we want to calculate the value of this V dV, dx according to transposition goes in the right side. V dV is equal to minus 2x dx. Now what we have to calculate the value of V, so integrating both sides. In the left side we are integrating with respect to V, so the limits of V is V1 to V2, and the right side the limit from x 0 to x. Why we have put initially the displacement is 0 and the final displacement is x. Initial velocity is V1 and final velocity is V2. On solving integration and applying limits, we get V2 square upon 2 minus V1 square upon 2 is equal to 2x2 square upon 2 with minus sign. Okay, now what we have put in, the values are given this in format, but the question is according to kinetic energy, so you can see we have just multiply by m. Okay, because we know the formula for kinetic energy is half mv square. V square is there upon half is there, but what is missing? M. That's why we have multiplied this equation by m. On solving we get the values of n as 2. Okay, so which is our required option, n will be 2. So the difference of kinetic energy is in this format. On comparing this with this says 10 raised to power x, 10 raised to power x raised to power minus n, and this is 10 upon x raised to power minus 2. Okay, on just simply comparing we get n is equal to 2. This is our required option. Okay, moving to the next part. This question is related to ideal transformer. An ideal transformer with a purely resistive load operates at 12 kV on primary side. It supplies electrical energy to a number by nearby house at 120 volt. The average rate of energy consumption in the house served by the transformer is 60 kilowatt. The value of the resistive load in the secondary circuit in the mega ohm. Okay, this is simply the application of transformer. The relation for transformer says Vs upon Vp is equal to Ns upon Np, where Vs is the secondary voltage and Vp is the primary voltage, and Ns is the secondary number of turns and Np is the primary number of turns. Secondary voltage is 120, primary is 12 kV. 12 kV means 12,000 volt. Ns upon Np, and Ns is given as, we have taken as 1 upon 100. Ns upon Np is equal to 1 upon 100. Okay, so the first relation, Ns is not provided. Ns upon Np, on solving this we get 1 upon 100, and according to the question the transformer is ideal. For ideal transformer there is no loss. No loss means input power is equal to output power, and the power formula is V into I. Input power is the primary power, Vp Ip, and secondary is the secondary. The power remains the same. What is the value? That is 60 kW. K means 1000, that means 60,000 watt. Okay, on solving we get Ip is equal to 5. Okay, we get primary current as 5. Now the formula for resistance is equal to voltage upon current. Voltage is 12,000 and current is 5. We get 2400. For secondary resistance, secondary voltage upon secondary current, and on solving we get 240 mega ohm. Okay, 240. The answer is 240. Okay, moving to the next part. The next question is related to capacitor. A parallel plate capacitor with the plate area and plate separation distance is D, filled with the dielectric material of the dielectric constant K equal to 4. You can see we are provided with a capacitor. Plate 1 is this and plate 2 is this, and in between the two plates we have filled with which material? Dielectric. Okay, the total distance between the plates is D and the distance between the dielectric is X. Let C1 and C2 be the capacitance of the system for X equal to D by 3 and X equal to 2D by 3. This is for C1 and this is for C2. C1 value is this, and we have to calculate the value of C2. So this is just the combination of capacitor arrangement. C1 is equal to, we know the formula for capacitance of combination, general formula is E naught A upon D. What is the formula for capacitor? E naught A upon D. For C1, E naught A upon distance is 2D by 3 into 4 E naught upon the distance is D by 3 upon E naught A upon 2D by 3 plus 4 E naught upon D by 3. On solving we get this relation. Okay, and according to question the values are given in this format. So on solving we get E naught A upon D is equal to 3 by 2. Okay, same calculation is done for C2, so the answer comes out to be 3. So capacitance for C2 is 3. Okay, on solving for the system of capacitors. Now moving to the next part. Two identical solid spheres, each of mass 2 kg and radius 10 cm, are fixed at the ends of an lightning rod. The separation between the center of the sphere is 40 cm. The moment of inertia of system about perpendicular axis theorem. We have to calculate the moment of inertia, and according to which theorem? Perpendicular axis theorem. Now the parallel axis theorem says the moment of inertia of system is equal to 2 by 5 mr square plus md square into 2. Why we have multiplied by 2? Because two identical spheres are there. 2 by 5 mass is, according to question 2, r is 10 cm. We have converted into meter. Okay, and solving distance between those 40 cm, that can be written in meter as 0.04, and the solution comes out to be 176 into 10 raised to power minus 3. So the required answer is 176. Okay, moving to the next part. A person driving car at a constant speed of 15 meter per second is approaching a vertical wall. The person notices a change in the 40 Hz in the frequency of this car horn upon reflection of the wall, the frequency of the horn. This question is something related to this. A person is moving in a car and when it horns, so the sound wave reflect back. Okay, the real frequency and apparent frequency. So f dash is equal to f naught plus 40, and for solving f naught we get f naught 330 plus 15 upon 330 minus 15, because 15 is given as the speed and 330 is the speed of sound. On solving we get f naught plus 40, and putting the values we get f naught as 420 Hz. This can be simply solved by just the application of conceptual knowledge. Moving to the next part. A pole is vertically submerged in a swimming pool such that it gives the length of shadow 2.15 meter within the water when the sunlight is incident at an angle of 30 degree with the surface of water. If the swimming pool is filled to a height of 1.5 meter, then the height of the pole above the water surface in centimeter will be. This question is somewhat related to refraction of light. Why refraction of light? Because in swimming pool water is filled, and above which medium is there? Air. This is air and this is water. So okay, so we have drawn this type of diagram. Now if vertical pole, according to question, a pole is vertical submerged in the swimming pool such that it gives a length of shadow 2.15 meter within the, we are provided with a pole which is submerged, means it is inside water and some part is outward, and it gives a shadow of 2.15 meter. What angle of incidence is there? 30 degree. Swimming pool is filled with a height of 1.5 meter. So the swimming pool is filled how many times? 1.5 meter. We have to calculate the value of this y. So according to the laws of reflection, sin 60 is equal to 4 by 3 sin r, mu is equal to sin I upon sin r. Solving for sin r we get 3 root 3 upon 8. If we are provided with sin r, for refraction we write mu is equal to sin I upon what value is there? Sin r. Okay. For solving we get sin r as 3 root 3 upon 8, and if we are provided with sin r, we can calculate cos r as well as how we have calculated sin square theta plus cos square theta is equal to 1. So sin r is 3 root 3 upon 8 and cos r is 0.75. Tan r is simply dividing the both values, we get the values of x as 1.275 meter. Okay. Now tan 30 is given as how many? Y upon 2.15 minus 1.25. Why? Because the shadow is of 2.15, and for solving x we get 1.275. That's why we have subtracted 2.15 minus 1.275. On solving we get y equal to 0.50. So the length of pole above the water is 0.50 meter or 50 centimeter. This is the required length y which is above the water level. Okay, this is also the question which is covered under the topic refraction. So this is all about some of the JEE questions. In the next video lecture we will also discuss some more questions having some more conceptual knowledge. Thank you.